we take each class of the materials and we reinforce them, and as a result we get better properties. To control the process, to control the structure, to control the properties. That is the main idea. It's very easy to remember the classification of composites because they go after three major classes: ceramic matrix composites, metal matrix composites, polymer matrix composites. Reinforcement, particle, fibers, or structural. The idea is for address a drawback of the class of materials in general. And for metal matrix, making a composite can increase the elastic modulus, the yield strengths, and creep resistance, creep performance. For ceramics, we address the fact that the ceramics are brittle, so there's increased fracture toughness. For polymer matrix composites, there's increased ratio of modulus divided by the density, or tensile strength divided by the density. Particulate reinforcement, we can have large particles or dispersion strengthening. If you ever drive on the 42nd Street, they put those roundabouts. You cannot go fast. There's no stop sign. This is roundabout. You don't have to stop, but you have to take a turn with your car, so you have to slow down naturally. And also, problem with composites in general is anisotropy, but with particles reinforcements, it's more or less isotropic, because those particles are most of the time round. For fiber reinforcement, we can have continuous, aligned, or discontinuous that can be either aligned or random. And the orientation of the fibers has to coincide with the axis of the load to give you this effect. And we discussed isostrain and isostress conditions. But for properties for the fiber reinforced can be either isotropic or anisotropic. And the structural, we talked about sandwich panels and laminates. That's it about composites. Is that this thing is really old, but the rust on this part occurred when it was brand new. This is a shaving cream. Okay, so how do you apply a shaving cream? Well, your hands are typically wet, right? And you squeeze, it depends on, you need to use both hands to do it. So you press on this button here, and the shaving cream is released, right? And you get it on your left hand, or you go like this, and then you apply. You're not spraying it directly onto your body to shave, correct? Okay. So then the actual shaving cream has certain moisture in it, and I don't know if anybody used this particular brand, but after you dispense this cream, it continues to dispense it, so it accumulates here. And what do you do to prevent this foaming? Because you're making a mess in a way. You stop pressing, but it still continues. It's a poor design. It's not like a perfect design. How many are familiar with dispensing a shaving cream? Okay, so think about how you do it. You press on this button here, you get some of it, and then you use it, right? You apply it to whatever parts of your body, that you're shaving, right? And you shave, and then in the meantime, this thing, you don't need it, right? So you set it aside. Next time, and I don't care what brand, but what you're going to notice is that there is going to be excess shaving cream coming out of here, residual. And it can be relatively large blob depending, and what do you do with it? Clean it up. How do you clean it up? You wash it off. Wipe it with what? How many of you wipe it with a piece of paper? Do you wipe it with a piece of paper? Wash it off. Not whatever. But we're comparing two options. Wipe it off with a baby wipe, which means that you're wasting a baby wipe on this, versus washing it off. How do you wash it off? Under running water. Okay. And then, as a result of this running water, what happens? There's water that is resting on this part, okay? And then, before you know it, before this thing is gone, this part is completely rusted. So it's not like because I dumpster dive it from the can. It's the one that I personally used, and it rusted while it was used. Okay? It brings several problems and several issues. Number one is aesthetics. It does not look very good. The other part is hygienic, right? Because you are dispensing this and some of this rust can get on your skin. Who knows? I mean, it's not like a big deal to get iron oxide on you. But do you see the point? Okay. I stopped using this. I don't use shaving cream anymore. I just use soap. I'm going to pass this around so you can look at it. Again, over here, there's that shaving cream. It's this, I don't know how old this thing is. But what do you think of this? Because it's performing the same function as this, and I don't have to deal with this. And it's just more, because I've been traveling so much, you cannot take this on a plane unless you check it into the bag. A friend of mine, what? Shaving oil. I haven't thought about that. My friend just went to Rome and came back. That guy that does dog books, he traveled with his wife and two daughters. And they had to take luggage. They took 2 bags. It was $160 to check in every bag. And I'm sure they needed all the stuff that they brought with them. He didn't bring anything that required a luggage. Well, I mean, that needed to be checked in. On the way back, they had overweight. So he paid $160 for each bag, plus another $100 for the overweight because they bought limoncello or whatever. I said, bro, you can go to Costco and pick up the stuff for $20. It's much cheaper than spending 800 and something whooping dollars on just hauling your luggage. You know what I mean? And stuff like this, you cannot take into your backpack on the plane because of this is 10 ounces, 9.5 ounces. So this is over the limit. But this is a side story. Whenever you travel these days, just be aware that when you go to the airport and you have to check in your bag, it's going to be $100 to check it each way. So for $200, there's a lot of underwear you can buy, or I mean, healthcare products or whatever you need. You know, just a thought. And then you have these videos on TikTok that go viral when they put a lot of clothes on them. Have you seen that? I've done it one time. There's but because in my mind, $160 to check a bag one way is a lot of money. I don't know what you think about that. If you fly on Frontier, they say they're going to charge you, but they haven't been. But sometimes they are not nice to you and they do charge. So There are lots of airlines in Europe, like low coasters, Wizz Air, Ryanair, and they are allowing a backpack, but it's the size of, this is the size, half of the size of the normal backpack. And I can tell you a trick, if you, so the, you have to pay for carry-on. And it depends, you know, it could be, it's less than $100, but still. So what you can do is you go to duty free and you buy something. I bought Jägermeister in Germany when I was flying to Italy, and then they give you a bag. So in that bag I put my laptop, I put my 2 cell phones, and then I needed to bring a jacket for my wife. So I put it on actually, and then I put another jacket. So I didn't do quite that extreme that you see in TikTok, but it worked. Yeah, I took my daughter's backpack, which is half the size, you know, little when she was a baby. But they weren't so some people, if they see like a backpack like this, they make you stick it into the thing, and then they charge you the last minute, and it's twice what you would pay online. You know what I mean? Okay. How many of you are going to be traveling in the summer? No? Want to travel? Okay. Well, the reason I brought it here is not to talk about travel, but to introduce a topic of materials degradation. And philosophically, it boils down to the minimization of energy. If you were not sitting, you would be laying down. If you were not in this class, you would be at home. And if at home, you would be sitting, and the lower energy state is laying down. Okay, that's minimum energy state, is laying down, doing nothing. Okay, and it boils down to thermodynamics and the Gibbs free energy. We studied refinement of metal from the ore, and if that metal is oxidized, it has a lower energy state compared to its metal state. Okay, so there's a driving force for this thing to rust, and that is philosophically what is going on. So, how many of you have ever observed something like this? You've seen it? What did you do with the can when it started to rust? Huh?
Nothing.
You used it and then you tossed it. Okay, I used it and I bring it to class to show. So this thing has a life of many years. Here we go. Just have a look. It's very explicit. I don't know why they're not because the bottom is yes.
Is there a reason to purposely cause rust on certain items? Because I have a knife and it purposely creates a thin layer of rust. I think it's to protect the knife more than anything.
You ask a very good question. Aluminum is the only one, is one of the metals that rarely occurs in nature. In fact, before the humans developed a process to refine and get the aluminum, its price was more than gold because it was so rare. It was impossible to find pure aluminum in the nature. Okay, so aluminum has a very thin layer of oxide, about 100 nanometers. It's naturally forming oxide layer, which protects, because aluminum is very corrosive and violent material. If you ever watch old movies when the photography was developed, you remember there was a wooden box, okay, and there was a guy who was covering his head with the dark clothes. Why were they doing that? Do you know? Because there's a photosensitive film, so that when he does that and looks to adjust, and then there was another thing and it went poof. You remember the flash? Okay. That flash was manganese alloy powder, which would ignite. See, I'm going to make it even more interesting. Whoever comes, and I'm sure there will be more students coming, I'm going to keep it up front, so they'll have to come in. So. $23. Can somebody come? $21, I count only. So it's 23 years. Okay.
Sorry.
Angie Rodriguez.
What?
It's gonna be easy.
What?
Nothing yet. Just wait. You're gonna be. Are you Rosas?
No, I mean, you call my name. What? What'd you say?
What?
You call my name?
I will.
Um.
Atil Kennedy. Old Nace. And there's the American Corrosion Society. If you ever get a chance to go to a national meeting, hot is questionable, but dry is the thing. 4 to 5% of gross national product is gone due to the corrosion. And it's estimated of $400 billion per year. And now, this was from the paper of 1998. How much do you think it is now? How much was the aid during COVID? Do you remember that Trump signed the first time? Is that $1 trillion? Anyway, this is a big deal. So, why is that important? Well, I'm passing around that container with the shaving cream. Most of the normal people would just toss it once they see the corrosion. And you will not be, no, you would use it? That's the ubiquitous container. You know what? I did not check. I was at Costco the other day. I should have checked because they had that. I need to check. If you ever go to Walmart or any grocery store, please check to see what that top rim is made from these days. There must be a reason why it's made from mild steel, which rusts, versus aluminum. There must be a manufacturing reason. So I don't know if 20 years later they still use the same material. Okay. There are two types of chemical reactions. There's an oxidation reaction, and there's a reduction reaction. And if we, for example, take a look at zinc, okay? Zinc in this solution can become ionized and release 2 electrons. So the solution becomes ionized. And the reduction reaction is hydrogen can attain those electrons and become hydrogen gas. And on the surface, when zinc becomes ionized, it leaves the surface. So you see there's a void here. Material just leaves the surface. It deteriorates. Okay, it's being spent or dispensed. So in the acid solution, these are the two reactions. In acidic solution, we have oxygen plus the 4 hydrogen plus the 4 electrons gives us water. If the media is acidic or is neutral or basic, then oxygen reacts with water and the electrons and forms OH minus groups. So you realize that the solution can be either acidic, or it could be basic, or it could be neutral. In the end of the day, it doesn't matter, we're screwed. Because there's oxidation and reduction reactions happening all the time. And besides the material deteriorating and leaving, the other problem is hydrogen. And what's the problem with hydrogen? What is the smallest atom? Yes, sir.
Are you saying the molecule or the
Either or. Atom. And how big is it? It's tiny little guy. Okay. Let's talk about standard hydrogen electrode. We take metal and we take platinum as a reference. And we put both electrodes into the solution. And we hook up a voltmeter. There is going to be current flowing because platinum electrode and metal form what's called a galvanic pair, a battery more or less, because these are dissimilar metals. We can reverse this process and actually apply the voltage, and that way there will be a electrodeposition. So these are the two inverse processes. So if this voltage is less than 0 relative to platinum, or it would be higher relative to platinum, we're going to have electrodeposition. Okay, so in this case, for corrosion, there's going to be loss of the material. In this case, there will be the deposition, electrodeposition. So these are the two opposite processes. And then there's a standard EMF series that measures this corrosion potential, right? You can see here gold and copper. Gold, these are more cathodic and these are more anodic. And if you take two different metals, like for example nickel and cadmium, you would see that the delta V is 0.15 volts. Have you heard about NiCad batteries? If you take cadmium and nickel and you put it into the solution, there's going to be voltage generated. And this is how NiCad battery actually works. A different subject. What is the problem with lithium-ion batteries? Yes. Too reactive. And what does that mean? Why? Okay. Do you know what is the swelling of the electrode in a lithium battery when it's being charged? It's 400%. This is why if you are flying, you're not allowed to check a lithium-ion battery in your bag if you travel with any Chinese airline. It's forbidden. So do not check your laptop into your bag when you're traveling to China or from China, or if you're traveling with any Chinese airline, because they're going to physically take your laptop and keep it, and that will be devastating. Have you heard about that? It's the first time I'm telling you. You are allowed, however, to take your laptop or the lithium-ion battery with you on the plane. You're not allowed to charge it in flight. It could be devastating. Your $2,000 laptop is kept in Guangzhou because you had it. Can you imagine? It didn't happen with a laptop, but it happened with a friend of mine who had some sort of a device that had a lithium-ion battery. I don't know if it was a electric toothbrush, but they confiscated it and never to be seen. And there's a reason why they do it. Why? Because the battery can explode when it's being charged, or it can explode when it's touching moisture. And when we had hurricanes in Clearwater, 2 houses burned down because Tesla got flooded with water. And the whole house burned because there was a Tesla inside the house. And my Toyota Prius is the last one from 2012, where they used NiCad batteries instead of the lithium battery. So I'm safe. Driving this car, if it gets flooded, it's not as efficient, it's not as good as lithium battery. So I want you to think is reverse to the electrodeposition. And the problem here is that there's no external power or anything. You just take 2 metals and you put it in the solution and you get electron transfers, which means that there's going to be current flow. Corrosion in a grapefruit. You can take a copper wire and you can take a zinc wire and you can stick it in there in the grapefruit, which is acidic, and you're going to start to have corrosion of the oxidation reaction of zinc. So zinc is going to go into the solution as an ion and give up 2 electrons, and the hydrogen is going to get that those electrons and form hydrogen gas, and the oxygen is going to react with hydrogen and take those electrons and form water in the presence of acid. This is a really big deal. Civil engineers in the audience? Anybody? Yes, okay. We talked about composites last time, right? And a composite, reinforced concrete is a composite, right? I'm going to ask you a tricky question. Let's say there's a floor. Like this building is 1 story, but you go to any other building and it's 2 stories. So there's a slab. Where would the metal be in a floor? Is it going to be close to the surface, or is it going to be close to the bottom of the slab? And why? Yes?
Which way would it bend? Which way would bend downwards, right?
Yeah.
So you would put it on the top part.
For the floor. So here's my floor. It's supported like this. I'm walking on it. Where's tension?
No, on the bottom.
The bottom. Okay? All right. Now imagine there is a balcony. And it is a cantilever balcony. So this is a cantilever. And you're walking on it. Where would you put the rebar in that case? No, in this slab. So this is a slab. On the top. Okay, so you would put the rebar on the top. And the closer the better. But what's the problem with putting it on the top? If you're in Clearwater Beach? Diffusion, right? salt water can go in and react with metal. And the problem is that rust, which is iron oxide, takes 10 times more volume than the metal itself. So it starts to react, and literally this thing explodes from within. It does not explode, but it expands, and as it expands, the concrete starts to spall. There's one building that spent $4 million resurfacing the balconies, and the damage was repaired. The building was put together in 1929, and then there's a movie on YouTube called The Dinner for the Soldier from 1944, and then it sat there during the Second World War, and eventually the building was built in 1962. So that's how old it is. And of the original design, the balconies were enclosed, so they were not exposed to the moisture, to the rain, to all that. There's several design flaws of that building. The balconies are sloped towards the building. And I guess whoever made that, so why not slope them out evenly? So when it rains, it pours, right? No, they sloped them towards the building. So the water runs towards the building, and it's supposed to run sideways into the specially designed cast iron pipes, and those cast iron pipes were gone since 1962. Okay. Corrosion. Temperature effect. Okay, so we have the potential of 0.15 volts. If we are changing the temperature, then there's an extra term that's added here. RT over NF log of X over Y, where the N is the number of electrons per unit oxide or reduction. In this case, it is 2. F is the Faraday constant, 96,500 Kelvin per mole. So you can see here that either increasing X or decreasing Y or increasing T has the same effect, because this part is subtracted for. Normally, you increase the temperature, and this is when you do it in the non-standard solution, right? X moles of whatever stuff and Y moles of the whatever non-standard solution we have. And typically, this is the problem with corrosion, is because you have to figure out what's that non-standard solution, right? It could be salt water, it could be rain, it could be acid rain, it depends really. There's another rule that if you need to do corrosion mitigation, then for $1 spent for corrosion prevention, you would spend $100 with mitigation. What does that mean? Let's say somebody painted this wall, and there's something wrong with the application, or there's something wrong with the paint, or there's something, or the substrate was dirty, and this paint starts to peel, or it locally starts to delaminate, or there's any other problem. How would the mitigation look like? Can you imagine stripping this paint from this large surface? But that what needs to happen is to get rid of that before you reapply anything else. And this is why, corrosion protection is a big deal. We can do the same ranking in the presence of the seawater. And these are more, magnesium and zinc are the worst, and platinum and gold and graphite, titanium are better. My PhD thesis was on metal films adhesion for semiconductors. And if you go in the Kopp building, if you go to the bathroom, I haven't been to the female bathroom, but the male's bathroom, I assume you have the same thing. But next time you go, please notice that you would see that the the bottom of the mirror, where you wash your hands, the bottom of that is all delaminated. Okay, so I knew that adhesion is weakened in the presence of moisture, in the presence of water, and my first grant was from NACE, which was actually administered by NACE from the Office of Naval Research. And I spoke with the program director, and she said, Alex, all of this is great, but all I care is all of those ships that are out there that are rusting, I cannot have them to rust. I cannot have them rust. So it was a very good time. And this is the deterioration of a mirror. And this is an old coating, metal coating. These blisters are induced by an indent, you see? And the reason the delamination propagates is because there's residual stress that drives this delamination. And we performed this test without the presence of the moisture, and this one is with the presence of the moisture. So water reduces the adhesion by at least a factor of 10 of a thin film over coating. So this was done in the same input, right? And the lower, the smaller the blister, the better the adhesion. So this is the wet indent, this is the dry indent. NACE, American Corrosion Society, is a very big exhibit. They typically have an annual meeting in Houston or sometimes in California. My advice to you, if you ever have a chance, like you're associated with the Student Society, right?
I am, yeah.
Okay, are you an officer or are you just a member?
Just a member.
How about you?
I was executive board member.
Well, why you're not affiliated anymore?
No, I'm affiliated. I'm just not like an executive board member.
It's okay.
Because I'm about to graduate.
And how about you? What's the society?
Civil engineers?
American Society of Civil Engineers.
Yeah.
Okay. Where's the annual meeting?
I don't know. I think it moves around. There was just a meeting in Boca Raton, though.
Did you visit?
Yeah, I was there.
Okay. And the society paid for you?
Yeah. Well, part of it.
Okay. Did you enjoy it?
Yeah.
Okay. So, for the rest of you guys, you're getting a bachelor's degree in your respective field, industrial, civil, or mechanical, right? And then you're going to graduate. You're going to have your resume. Unless you have specific job experience, which is what companies are looking for, how are you going to be different than your peers? So a society is a great way to get involved. There are a lot of benefits by joining the society. It's a professional society. It's either going to be free for you as an undergrad or minimal cost, like $25 a year, right? Do you have to pay dues?
It's free for students.
How about you? Also free?
No, ours are more than that since it's a fraternity and we have a lot of events.
How much is that?
It's like, I believe $275 now.
$275 a year?
A semester.
Oh, a semester. You get that money's worth, right?
Yeah, we have a lot of events.
Okay.
A lot of free food. Well,
Free food?
free after you pay dues.
Yeah, I know. But it's not about the food, which is you know, is good, but it's about your professional development. Okay, so can you tell me roughly what you've seen so far? What are the two main processes involved in corrosion? What's rust? Iron oxide, okay? So one part of the corrosion is oxidation, and another part is reduction. Very good. Typically, what you are mostly familiar with is uniform attack. And the uniform attack is this, where the whole surface is corroded. It's very noticeable, right? The other type is selective leaching, when there's preferred corrosion of a certain element. Like brass, for example, is an alloy of copper and zinc is going to be more reactive. So if you ever seen corrosion of zinc is leaving the alloy at a higher rate than copper. Okay. The other one that we actually use in microscopy is called intergranular corrosion. And it happens along the grain boundaries because there's high energy associated with grain boundaries, and they get attacked first. So the removal rate of the material at the grain boundaries is higher, which allows us to have better contrast when you watch this in the optical microscope. Stress corrosion. This is when there's a combination of corrosion and externally applied stress where the structure is under load. Galvanic corrosion happens when you have dissimilar metals that are joined together, and one metal is more anodic than the other. You form a galvanic pair. Erosion corrosion is a combination of chemical attack and mechanical wear, like in pipe elbows. Pitting corrosion is very, very bad. How many of you have heard about stainless steel? Okay. What is stainless steel good for? It's not supposed to rust. But does it? The mechanism of corrosion of stainless steel is different. So you're not getting uniform attack, but you get pitting corrosion. And pitting corrosion is very dangerous because it happens in a very small localized area and you end up with a hole. And inspection does not always allow you to see it. There's also crevice corrosion, and these are rivet holes, and by putting a washer or a rubber nut or anything like that creates anodic and cathodic regions. And what happens is this electrochemical attack is preferential. So at a very small area, it's all about per area. So when the area is very small, the etching rate or the removal rate is very, very high, and the material it just leaves. Okay, how do we stop corrosion? One idea is to use a sacrificial metal or a metal that is not going to corrode, like passive. The word is passive or passivation. It forms a very small layer, like on aluminum or in stainless steel. There's passivation. Because either use a material that's unreactive in a specific environment, but you need to know what their environment is. So the problem with that, if you change the environment, if it becomes acidic versus basic versus neutral, it can cause a problem. One of the reasons why I'm actually was teaching materials 2, which is material selection and mechanical design, is because in mechanical engineering in Florida specifically, do you know what's number one field that's not affected by the economy? Do you know? Do you don't know? Is it comfortable in here? Not too hot? What about in the summer? Still gonna be comfortable? And why is that? HVAC. Okay. So even if you don't have the money in Florida and the AC goes out, you will pay. You will take a loan and you would fix the air conditioning system because it's very important to there's a sign-up sheet. So air conditioning in Florida is a business that you can never miss. They're always going to be good. Lower the temperature. Why? Because it's all about that exponential dependence on the temperature. Apply physical barrier, a film or a coating. Paint it, but it has to be the right kind of paint. There are special materials which are called inhibitors. These are the treatment additives that are added into the solution to reduce its reactivity. Slow oxidation or reduction reactions by removing the reactants. Get rid of oxygen with the help of the inhibitor. And finally, there's sacrificial or cathodic protection. If you add zinc on steel, zinc is going to decay first. The other option is to put a sacrificial anode. And that's exactly what they've done on those balconies. The problem is, once you place this material inside the concrete, they did not put them low enough. So once this thing deteriorates, because it's expandable, you end up with a hole. So you have to be careful how you do it. And what I want to show you is that when we're going to be talking about electrical properties, which is coming soon, duplex stainless steel has the two phases, alpha and gamma. And what people have noticed that in the corrosive environment, in iron chlorine solution, the pitting always starts in the gamma phase. And there was no explanation why this was happening the way it was happening. And it turns out that the reason was, this is the current in nanoamps between the alpha and the gamma phase. And the most of the current spikes you see are along the grain boundary. And this is the reason why even the passive film on the duplex means two phases, alpha and gamma. This is an awesome picture. What was the estimate of the loss of corrosion per year? That was in the 90s, end of 90s. Percent of GDP never changes. What was that again? Roughly? 45%. How much do we spend on education? It's a good idea to look those numbers up. So this is a big deal. There's only maybe a handful or a couple of programs in the United States that you can be a corrosion engineer. Ohio State University is one of them. They do have a program. And the reason is it's so big deal because there are not enough corrosion engineers, and it's not just enough to know the material science. You need to know electrochemistry, you need to know a lot of stuff from electrical engineering, from mechanical. So it's kind of like a lump sum. But you can get a degree in corrosion engineering if you go to Ohio State. And I wish there were more programs in corrosion. I'll see you next week.
Hey sir. Can I ask you a quick question?